everyone. I'm really excited to be here. So, yeah. I'm Vidhi Kataria. I work as a software engineer. I worked as a software engineer at Geeky Ants, and I have been working extensively with the UI tools to support the UI libraries that we have built. And as for Geeky Ants is a design product studio that does everything related to web and mobile app development. So, yeah. Uh, Topic for today is maintaining large code bases. There will be few agenda that we'll be covering today. First, we'll be discussing what are code bases, what isn't a code base, different solid principles, monorepos versus polyrepos, then how to handle a shift from polyrepos to monorepos. So, what are code bases? Let's start with the first one. Most of you might already know it, so let's discuss this quickly. A code base is a complete body of source code that is required to run your application at one single location. Yeah. Suppose you are creating a node server, you will first create an index.js file. Yeah. And you are running a server that can help that handle HTTP requests. But since it's hard to write server endpoint this way, later you decide to use Express in your node server. So for that, you will create a package.json file and you will install the node modules. So initially, uh, initially when there was just one file, even that was considered as the part of your code base. And now if you have multiple files, that is also considered as the code base. And as the application grows, there might be Docker file, different assets, and many other files as well. Code base is a very generic term, and many developers use it to define different aspects of code or different features sometimes as well. But let me tell you what isn't a code base. A code base is not the minified bundle that is executed by the computer. Instead, it is the files or the it is the source code on which developers work. In case of a React application, the build folders are not considered as the part of the code base. Instead, the JSX and TSX files on which the actual code is written by the developers. In simple terms, whatever goes to your Git remote can be considered as your code base. When you start an application, there might be 2 to 3 files, but as the application grows, there might be thousands of files. So maintaining code base become an important aspect. So to do that, we can define different code rules. We can define different style guides, like defining style guides or maintaining a design system so that all the components and user interfaces can maintain a consistent design. We can define different linting rules. Linting rule refers to how the code is written, spaces required between the lines, are there comments added where required or not. Having a well-defined folder structures is also considered as a good practice. After you set up these 3 things in your code base, there are some more improvements possible with the code base maintainability. We can follow different architectures like monolithic or microservices architecture. In monolithic application, there is a single unified code base, while an application following the microservices architecture has multiple independent services. Which architecture is more suitable for your use case depends on the team size. Monolithic architecture is better for a single developer or small team, whereas microservices may be better if you had a skilled team and you plan to expand. Other factors also include application complexity, application lifecycle, and application size as well. Another pattern that we can implement are coupling and cohesion. Coupling refers to the level of interdependency that different modules have on each other. It is recommended to have low coupling and different modules must be as independent as possible. Cohesion is the degree to which elements are able to work together within a module, and high cohesion as it makes system easier to maintain and improves readability of the code base. Suppose we have a web app and we divide it into 3 different layers and allocate responsibility to each layer clearly and separately. Like all the UI logic will be confined to the web layer, all the business logic will be the responsibility of the business layer, and data storage and retrieval would be taken up by the data layer. This is the example of cohesion at the application level. Each layer is highly cohesive because it does a very specific thing, whether large or small. In this case, we do need a little bit of coupling, like data retrieved by the data layer will be used by the business layer, and user interface will make some API calls to get past data from the business logic layer. In this case, we can see only the relative coupling is present. But suppose I say that the business logic is handling how the UI is visible, then that is a example of unnecessary coupling and should be avoided. Next, we have solid principles. In terms of modern architecture, solid principles states single responsibility. Principle states each module should do one thing and do it well. This principle is similar to high cohesion. Essentially, your code should not mix up multiple roles or purposes together. Then we have open close principle that you should be able to use and add to a module without rewriting it. In functional programming paradigm, your code has to define explicit hook points to allow modification. Then we have Liskov substitution principle. In this, you should be able to substitute one thing for another if those things are declared in the same way. In dynamic languages, the most important thing to take care from is that if your program promises to do something, such as implement an interface or a feature, you need to keep your promise and not surprise your clients. Next, we have interface segregation principle. Don't show your client or users more than they need to see. Only document what your client needs to know. This might mean using documentation generators to only output public function or routes and leave private ones unemitted. In microservices world, you can either use documentation or true separation to show clarity. Next, we have dependency inversion principle. It promotes loose coupling between the components. It states that high-level module should depend on abstraction rather than complete implementation. Sorry. Yeah. Then you need to understand the concept of monorepos or polyrepos and how they make the maintenance and development process easier or harder based on your use case. Monorepos are most widely adopted nowadays by many large organizations, and they make our life much easier. Let's discuss them in detail. I'm not going to tell you the definition of monorepo. You will find it on internet easily, but we'll try to understand what it is from a case study or a scenario. Generally, when you initially start your project, your entire code base is somewhat of a monolithic service or one repo where all the code is present. It can have multiple routes, API, multiple clients. We have everything in one single location and everything was going fine. Sorry. Yeah. Yeah. But with time, as the application size increased, we needed a dashboard and few other clients. Let's say it needed to be made with Next.js, and maybe the previously mentioned service was made with Angular. These are different repos which do not have much dependency on each other. So we can separate them and consider each one of them as an individual service. There are, again, two ways to do that as well. One would be to consider each service as a different package and have them in a same repo. Next would be to have a different repo for each service. In the first point, we were discussing about the monorepo structure, where we have a single Git repo at the root of the project. And anytime a code is committed, it is synchronized with all the other apps of the project. And it also gives us a centralized place to manage issues and pull requests. A popular example is React repo itself. It has many packages and they use the same versioning, and there is no question if they are using the right package or not. To implement mono repos, right tooling is a very important part of it. As the code base increases, it is difficult to manage monorepo. That's why large organizations created their own tools, like Microsoft created Rush Stack, Facebook created Buck, and Google created Bazel. Another most commonly used tools are NPM and Yarn workspaces, which has a root level package JSON, and that has nested workspaces, which can be linked back to the root project. Then there are another tools like Lerna. Lerna streamlines the development and the collaboration of projects at large scale. It automates tasks such as versioning, dependency management, and project linking. It increases the organization's scalability and increases the scalability of interconnected packages in a single repo. Next, we have NX. NX is a bit similar to Lerna, but over that, it is full-fledged development toolkit for monorepo projects. It extends the capabilities of Angular CLI to support not only Angular, but also other frameworks like React and Node.js. Next, we have TurboRepo. TurboRepo is a toolset and framework agnostic build system that can integrate with package managers like NPM, Yarn, and PNPM. It uses caching to speed up the local setup and CLI. TurboRepo speeds up the task through smart scheduling, minimizing idle time, and optimizing CPU utilizations. Yeah. So let's look at our journey and the problems we faced while development. We had built Nativebase. Nativebase is a UI component library which provides universal accessible components. But internally, a UI component library has many parts, like a styling engine, or another library that adds accessibility, and another library that adds functionality to the components, and much more. Initially, we had a single code base that managed all these features, and as our UI component library grew, we realized separating these concerns makes more sense for us as we had wide audiences. So, suppose you want to just use the unstyled component without theming, there was no way to do as there was tight coupling and the components did not work without theme. So keeping this issue in mind, we decided on building a new component library, which we call the successor of, which is the successor of Nativebase with a completely new architecture. We use this opportunity to disintegrate one single code base into multiple Git repos. And this gave birth to GlueStack ecosystem. Now let's try and understand how this ecosystem works. We take a React Native component and then we pass it through the styling engine, that is GlueStack style, which adds theming to it and gives us a styled React Native component. Then we had another library, that is the GlueStack creators, which would add component level functionality. And then with the help of React Native ARIA, we added accessibility to the components. This process was expanded to create design systems as well. Each package is an individual library and could be used that way. We worked with the same pattern for almost an year, and after doing stable release of each library, everything was going well for us. But since this is an OSS project, it was inevitable that issues will be reported by the users. But the problem arose when we tried debugging those issues, because all those issues were reported on one single GitHub repo. Now the developer had to backtrace the issue from the component library to the accessibility library or the styling engine or the functionality adding library. This created a lot of inconsistency in the versioning of each library in each reproduction. Thus, then we decided to move everything to one place, as it would be easier to maintain and debug. Now we face another new challenge. That is, since this is an OSS project, we can't just simply copy paste everything in one repo. We needed to retain the Git history so that the people don't lose their contributions and developers their accountability. Here's where the interesting parts come and how we solve this. We will quickly go through a quick demo and how we can move multiple repos into a single Git repo with Git history. First, yeah. Here I have just created a single mono repo using Turbo Repo template. It just has few packages in it. Next, I created a random next project on in the same directory, and I committed it on Git with a certain Git history. Now, what we will do is we will write a quick script that will move all the files that we want to shift to that mono repo using the git mv command. What this command does is this will copy the file to a new folder, retaining the Git history for it. Yeah, now I'll just yeah, we are just writing the script. This will get all the files except the node modules and the script itself, and it will run the git mv command and move all the files of the next project to a new folder, which we will call next-app. Now we have all the folders that we want to our mono repo inside, all the files that we want to mono repo inside a new folder. Then we'll add the remote new origin, new remote using the local linking. I'll link the next app and add its remote in my mono repo. And when we'll check git remote, we'll have a new origin. We just simply need to fetch it now. After doing that, we'll create a new branch that will fetch all the files that we created inside the next app into a new branch, which is the new origin. Now we'll just go to that branch and remove all the extra files which are not required inside the packages. We'll do a quick cleanup. And we can see that inside the next app folder, we have the Next.js project that was created. Now we'll just go to the main branch and pull from the new origin branch, and this will give us the next app on the root. But as this is a mono repo, we want to move this app inside the packages folder as well. And as we can see, we have retained the git history as well. Now we'll just use the git mv command and move next app inside the packages folder. Now we'll have a new package inside our app with the retained git history. So moving from mono repos to poly repos is much easier because each package inside is an individual package. We can directly move it. But if you have 20 to 50 different repos, it will be very difficult to do these steps for each one. So we had just built few libraries. That's why it worked for us. Many developers start with mono repo only, but in the future, according to their requirement, they switch to poly repos if required. So now let's compare these and check which will be better one according to your use case. So we'll discuss the advantages of monorepo. Monorepos give us better visibility to the entire company's code base because there is no need to clone bunch of repos. It provides consistency as well because we can maintain a design system, documentation, set same CSS rules, and list all the rules, linting rules for all the packages. Another thing that is made easy is the dependency management. Suppose if there is a package that has dependency on multiple package, so latest changes done in one package will be reflected in all the different packages instantly. Next, we can have shared node modules. If a common package is dependency is used by multiple package, it will be installed just once. Next, it helps in integration and testing, as all the different modules are already at one place. Integration testing is much easier compared to testing each component individually. Next, it also helps in CI/CD testing and setup, because we can use same deployment techniques for almost all the packages. Now, monorepos have some cons as well. If monorepo becomes large, or if your code base becomes very large, it can take a lot of time to build all the packages and deploy. That's why to operate monorepos on scale, large organizations have built their own tooling. And if during development there is a single point of failure, if one single Git repo stops working, then the entire code base can break. Or if some wrong code is pushed on the main branch, then all the other services will be blocked. Monorepos require more coordination among the team, and it gives us limited flexibility, as we cannot use multiple frameworks, multiple language. So if you have multiple languages in your application, monorepos can be a bit difficult in that case. So what to use depends basically on how big is the code base, what is the team size, total number of packages used, how many packages a team needs to work on at a given time, how tightly coupled are the packages, how much flexibility is required, what is the culture in the company, does the company encourage collaborative teamwork, and what technologies do team work on. Thank you everyone for listening to me. I hope this will help you in some way. If you have any question or doubt, you can ask me. I'll be available here, and you can also DM me on Twitter.
So, yeah. Any questions, everyone?